And we're live. So you guys can put matrices and solving systems of 3 equations in the past for a little while?
No, forever.
For a while.
For a while.
Are we going back to it?
I don't know your future, Raymond. I appreciate you believe in my omniscience, but despite the fact that I teach math, I am not a deity. Okay?
So do you ever get bored of like doing math?
No, I love my
Like
job.
doing the same thing over and over, and every year it's always the same?
No, because you know what? Every year you guys bring me all new joys.
Every year
and
you don't understand where I'm going.
How come every time you guys say it, I get a little bit more British with it? That bored me. So, anyhow, so today we're moving on, Module 5. We're going on to polynomials. Polynomials, which means we're exiting squared equations and we're going higher, right? So we're going to be hitting cubics first. That's what Module 5 is. It is a whopping 2 sections long. Mr. Ramirez, are you on your phone? Raymond Ramirez? All right. Thank you. I'd appreciate that. Okay. And he's still on it. I'm sorry, but he still goes back to it. Yes. Okay. So we're going on to cubic functions, which means 3. You just shook your spaghetti till some fell in your lap. I saw that. Don't worry. I don't know why there would be any reason to shake your spaghetti above your head other than to drop some in your lap.
I'm looking for the shrimp.
So, anyhow. So cubic equations, guys. Cubic equations. We're probably not going to get all the way through this.
So no homework?
We're probably not going to get all the way through this. We might not have homework tonight. We'll see. You just squeeze your apple. Yes, when you squeeze an apple juice container, believe it or not, any liquid container, the liquid will come out through the straw at above it. And you proved yourself wrong by squeezing it until stuff came out. Okay? You're not squeezing it. You're incapable of.
Nothing's coming out.
Okay. So, cubics, guys. Riley, Michael? Cubics. We can do everything to a cubic like every function. Every module is going to start off the same way, where we're going to be talking about it in the standard form. Who? Zelene, to the counselor. Okay. We can do everything to it. We can vertically stretch it. We can vertically compress it. We can horizontally stretch it, horizontally compress it. We can move it to the left. We can move it to the right. We can move it up. We can move it down. All those normal things that we can do to it, those are just changing the h and k values, changing our a values, and we are going to be using the b value in this first one if we're doing horizontal stretches or compressions. We should somewhat remember that, yes? If it's outside, it affects it. Outside affects it vertically. Okay, inside affects it horizontal. Okay. So let's first of all graph the standard cubic equation. The standard cubic equation is going to go through 0, 0, 1, 1, and -1, -1. All right. So Mr. Alfaro. Gabriella? My standard cubic equation goes through 0, 0, -1, -1, and 1, 1. Mr. Alfaro, what shape would you think that is if I just drew those 3 points? A line. But this is a cubic. Cubics change fast, but right around the quote-unquote center of them, they don't change much. But they change fast once you start moving away from it. Because what's 1 cubed? 1. Right, times itself 3 times with 1 times 1 times 1, it's just 1. That's why they're right clustered in a row right here. But if the second I hit 2, what's 2 cubed? 8. I'm nowhere in the realms of a line anymore. What's -2 cubed? -8. Okay, it's way down there. It's actually even further down by like another 1. So a cubic equation actually looks kind of like that. Let me, just because I don't mind the way that looks at all. I'll delete this one in just a moment. Just takes me 2 motions to get there. So there's our standard cubic equation. That is a standard cubic equation right there. that goes through 0, 0, 1, 1, and -1, -1. A standard cubic equation that goes through 0, 0 at the quote-unquote center of it. It goes through 1, 1, and it goes through -1, -1. Now, as we affect things horizontally and vertically, it's really rough for you in 6th period, isn't it, Mr. Glosson? It's really difficult to stay focused and attention, isn't it? Honest question. Is there anything I can do to help out with that? Because you are dead every 6th period. Nothing? Okay. Yeah. It's robotics. That's really funny. Robotics takes the life out of you because they are non-biological life forms without. Anyhow. Alrighty. Everybody okay with a cubic? Standard cubic? Okay. Thank you for the thumbs up while you were drinking. I appreciate that, Schnicker. Yes?
So it's called cubic.
This is a cubic, yes.
Because of the equation, not because of the shape.
No, it's because of the cube.
Okay, so it's not going to be a cube shape.
No. Just like when on the entire last module, Kaya, when we drew squared equations, they looked like that, not like this.
Oh, wow. Never knew.
So, alrighty. You guys want to know so really quick here, so this is a slight tangent. I apologize, we'll get back to this in just a minute. No. We'll get back to this in just a minute. So I was at a property with Mr. Brown, previous principal at this site and previous English teacher. And we were measuring a property together. And I was standing on the property with the couple that owns the property, and we were taking a look at it for measurements for the perimeter of it. Okay? And the measurement of the perimeter was very important to us. And so Mr. Brown goes, I'm going to, he's like, you know what? We were trying to like guesstimate how fast, how much a quarter mile, whether or not the property would be a quarter mile in perimeter, and if not, if it would be less, if it would be more, and whatnot. So Mr. Brown goes, you know what? This is stupid. Why are we sitting here talking about it? I'm just going to do this. And he opens up an app, and he starts walking away. And I know what he's going to do. He's going to turn on, like Runtastic or something like that measures the distance he's traveled, and he's going to walk around the perimeter of the property, which will get him exactly that. I kind of roll my eyes while he's doing that, right? And I look at the property owners, and I go, hey, this property, it looks about twice as deep as it is wide, right? And they were like, yeah, sure. Right, so we got this property that's like this, right? And I wanted to know how large it is. So I said, how big is your property? Let me get the actual numbers here. I said, how big is your property? This was yesterday. By a matter of fact, that number is still in my calculator. That'll be important later. Okay? So a little foreshadowing there. So I said, they said their property is 1 acre. So I said, how big is 1 acre, right? 1 acre in feet. Thank you. 1 acre in feet. And 1 acre was 43,560 square feet, right? So by the time I've Googled that, Mr. Brown's made it maybe directly to the fence at that point, right? So now if I call that X, how long is this? This is X. How long is this? 2X, thank you. Right? So this is 2X. So really quick here, the area of this would be 2x times x. The area of this is 2x squared. Be okay with that? Okay, so if I just take 43,560 and I divide it by 2 and I square root it. So basically I put 2x squared is equal to that. I get x was 147.5. So this is 147.5 feet. Okay? So then the perimeter of this is 147.5. 147.5 times 2 is 295. So this is 147.5. This is 295. Right? So I can add those all up. So basically I get 295 times 3. So the perimeter of this is 885. So the perimeter is 885 feet, right? The perimeter is 885. So now how many feet are in a mile? Feet in a mile, I believe, is 5,280. Or, yeah, 5,280. So 1 mile is 5,280 feet. So if I'm only going 885, I do 885 divided by 5280, and I get 0.167. So by this point, Mr. Brown's made it to the side of the gate, made it to that corner over there, and he's maybe at that corner over there. And I look at them and I go, this is 0.16 of a mile. He comes back around after walking it, and he's like, yeah, so it's a 0.16 of a mile. Yeah, I had that 5 minutes ago. Thanks. So sometimes the math is easier. So there's quadratics quickly and easily. Right, instead of, so I got to stand still for 30 seconds and find the answer rather than walking around it and finding out that. That was easier? I'd argue that me standing there was easier.
Well, some people need scratch paper in order to write it out. They can't do it in their head.
Yes, I did keep numbers in my head, I'll grant you that, but. Okay. Back to it, guys. Is anybody confused on what a cubic is? Okay. So now I'm going to move the center of it. I'm going to move the center of my cubic. What am I moving the center to, Kaylee? I want you to look at that, and I want you to think of everything we've done. What am I moving the center to? Oh. Welcome back. What do I move the center to? I need a coordinate, Elias. No. No. Holly, help her out.
You're moving the center?
Yeah. So this is the quote-unquote center of the cubic. That's where I could spin it, and it would look the same. Where am I moving that center to? Look at the equation that I'm comparing this to.
2-1.
No.
No, there.
What's my HK? 1, 1. Okay. So my new center is 1, 1. My new center is 1, 1. Now, besides moving to the right one and up one, what else is going on with this?
There's an extra one. No. Being multiplied by 2.
Yeah. What? Re-ask the question. So I said my center's moved to 1, 1, right? But what else is going on with this that's not in there? What kind of stretch? Vertical. There's a vertical stretch by 2. That 2 is out in front of it. That 2 is out in front. So here's something. Now I'm going to jump to the benefit of you guys being 6th instead of 3rd, right? 6th period instead of 3rd. Let me actually erase that really quick. So our original was, the center of it was at 0, 0. We okay with that? And then on a cubic equation, I go left 1, down 1, and I end up at -1, -1. All right? Left 1, down 1. And then I go right 1 and up 1, which puts me at 1, 1. We okay with that? So on my transformed, as Holly said, only my vertical is changed. Which one's vertical, X's or Y's? Y's. Y's are vertical. So my X's don't change. So I'm still going left 1 and right 1. I'm still going left 1 and right 1 because those are my X's. But I'm vertically stretched by 2. So instead of going left 1, down 1, I go left 1.
Is it right 2?
Down 2 is correct, Elias. Okay. Next one, right 1, up 2. What is left 1 and down 2 of 1, 1? What's left 1 of 1? What is left 1 of 1? 0. What is down 2 of 1? Negative 1. What is right 1 of 1? 2. What is up 2 from 1? 3. There is my vertically stretched by 2 transformed function. Vertically stretched by 2 transformed function. Questions, Elias? We'll get to those in the on the next part of it. On this one, we're not worried doing it. Any questions on this?
Oh, wait. I have a question, actually.
Yes, Raymond.
Why is it left 1 down 2 instead of like, well, I don't know. This doesn't make sense to me for some reason.
So I've only been vertically stretched or compressed. Here it's vertically stretched, okay? Which means horizontally, I'm not changed at all. So my lefts and rights won't change. My ups and downs will.
Oh, okay, I get it.
Yes. Yes. Why are we so inside of our hood today? Yes. You all right, Richard? Why does robotics just suck the life out of you? Huh? Mostly Kalani? Why does Kalani suck the life out of you during robotics? Does she frustrate you? How does she frustrate you?
Well, there's a reason we only have one instead of 2 buttons. Did you lose one? No, she stole it.
Kalani, you stole a button? She gave it back.
Only today, but it was barricaded for about 2 weeks.
The button was crucial. He was going insane.
All right. Are there any questions about this example, guys? I really need to know.
Do we need to draw those 2 things on the side down? We probably should.
It's a good thing to do. So why don't you guys do numbers 1 and 2 in your workbook really quick? Give you a...
Mr. Bates, I have a question. So do we only do that? Is there always going to be like a number on the outside? So what if there's not?
Then it affects the lefts and rights instead of the ups and downs. Just remember, in sides we do opposites.
Is it 5-1?
I'm tripping out.
Huh?
I feel dyslexic.
On the inside, that's about 1-1 here?
Yes.
Okay.
One and two.
Somebody at the door?
Mr. Bates, can you do me a favor? Underneath transformed where it's the 1-1, can you draw a little W under it for me?
Before.
Yay! So Brown versus the Board of Education was? I don't know. How do you not know? You have me now. My life is complete, thank you. Why don't you just check?
I did not call on you, sir. No, I did not. You assumed.
Ask Mr. Bates, maybe he knows.
Glosson?
Mr. Bates! I'm pretty sure it's Alabama.
It's been all right. You did say yours.
Missouri sucks.
What's funny about my face, Yeski?
You remind me of something.
It's like
No, his face was just going like this. So,
Mr. Bates.
Yes.
Brown versus the Board of Education.
Yes.
What?
No, it's Brown versus the Board of Education.
No, but like what's Alabama or Arkansas?
I want to say Alabama,
What's this about?
it's about.
but I could be wrong. It could act. I don't. It might not be either of those. Are you sure it's an A state?
No, I genuinely have no idea. Mr. Bates, doesn't it seem like it's an M state?
Yes. Yes.
I'm calling it an M state.
I'm glad that you guys are, working so hard on your workbook.
I'm doing both.
Kansas.
Mr. Bates.
Yeah.
What poster did you vote for?
Didn't ask me. Yeah.
It was so one I worried.
So,
Me and Kaylee already made amends.
all right.
Were you against them?
Did you guys do them? No. That was more than enough time.
Wait, okay. Mr. Bates.
I have this on place. I'm a little lost.
Yeah. Graph what it gives you.
So these are the HCK coordinates, so that goes there. And then because it's not being expanded or reduced, that means it's just like up one and over one?
Yep.
Nice, okay, thank you.
Mr. Bates. Three whole Y's. So this would be
Yeah. What do you mean?
So you go left one, down one?
From where? The center. Where's the center? No. Did you read the bold instructions?
Calculate the reference point of
So instead of negative 3, 2,
So they gave you the graph of the parent function. You've got to do the other one.
This looks like the same. I can't.
By the way, folks, when they say the reference points, these are the reference points. So 0, 0 became 1, 1. Negative 1 became 0, negative 1. 1, 1 became 2, 3. Do what you got to do. You done with it? How'd that matrix work out for you?
I got X pretty well, and then Y. That's the regional best translation we get into.
I'm going to quote you on it, Ross. Yep. Ross said she got it, and that anybody else, and that she'd bet her entire grade on it.
She says she thinks she got it. Oh, no. Mr. Bates, if you're interested in grading the test,
Nowhere near.
can you just like throw them away?
No, I can't.
I'm trying to keep my seat. I guarantee mine is going to go down to like
Okay. So we have our 3 points, right? We on the parent function, we've got 0, 0. We've got negative 1, negative 1.
That arrow is really good, Mr. Bates.
Oh, thank you. Okay, we've got 1, 1. I can't do a full coordinate for some reason. Okay, so we've got 0, 0, negative 1, and 1, 1. This one, where is the new center? 3, 2. 3, 2. Kermit the Frog here. So.
Who's Kermit the Frog?
Anyhow. Yes.
When you would move it, wouldn't you move it by up 1, over 1, and
Right, so there is no A on this one, Elias. You're correct. There's no A value. So I'm just simply going to, so my new transformed is 3, 3, 2. And I'm going left 1, down 1, and I'm still going right 1, up 1. So what's left 1 of 3? 2. What's down 1 of 2? What's right 1 of 3? What's up 1 of 2? There we go. And then do your best to make that, you know, curve. Yeah, I mean, try to get it as, like, you can make it as sloppy as mine, but that's like the sloppiest. That's fine. Yes, Cameron.
So if there's no a value in front, so like would this be acting like a slope kind of? Like it'd be like.
It's not exactly a slope, but it's a stretch because it's not a line. But yeah, that's
So
kind of
like
what's going
for
on.
this one, it's like it's 2, so this would be like 2 over 1 kind of.
Right, but that's because it's vertical. That's why it's affecting that the rise, not the run.
Okay.
Okay. Yes, Riley.
How did you get 3, 2?
So 3, 2 is my HK value. Did you do that, Holly? Good thing that you bet smart. So you won that bet. You get your grade stays right where it is. Good job. Kalani. She gave a 0. She bet all of it, you know.
Negative percent. Negative percent, Mr. Bates. A negative percent.
Pretty much.
And then a negative here, point out.
Okay. All right. All right. Where is my center, Cardinale? -2, -2. She's absolutely correct. Now, be careful. What am I multiplying? I have a vertical stretch by 3, but I also have what? A negative.
Does that mean it's compressed by 3?
No.
No.
What does negative out front do?
Did it? Does it change the direction?
Kind of. What do you mean?
I heard somebody say that it was
I don't know what like boom means.
horizontal instead of vertical.
Like boom. Huh?
Horizontal. Somebody
No?
said no.
It reflects it.
Oh.
It reflects it. So instead of being like this, it'll be like this. Okay? Not this. This. Negative in front. Flips it. Okay? So, what? A negative in front reflects it, right? So normally it ends high and starts low. Now it's going to start high and end low. Okay? So with that in mind, normally I'd go left 1, down 1. Now I'm going to go left 1, up 3. Thank you, Sione. Left 1, up 3. Normally I'd go right 1, down 1. Now I'm going to go, normally I'd go right 1, up 1. But now I'm going to go right 1, down 3. And you get a very stretched cubic equation. So let's get our numbers nice and easy here. What is left 1 of -2? And up 3 is 1. -1, -5. So those are the points that it maps to.
So for the answer, like where we put the points?
Right, so basically for the answer, this is on the line, the way it would look is you'd say 0, 0 becomes -2, -2. Right? This is what they would want the answer to look like. -1, -1 becomes -3, 1. I just like this visual format for myself better because I can follow it. 1, 1 becomes -1, -5. And I'd have to know what order your original reference points were in. Yeah. Okay? Well, we're going to do the note version of it first, because the notes version, at least, we're actually going to bring in some b values.
Are you for real?
Yeah, you.
Are you for real?
I'm for real. Sometimes I think I'm imaginary, and that this is really just a dream, all thought up.
Now you're my favorite teacher.
By
If you're
Kalani.
bringing in the B values, you're my favorite teacher. And you're the only teacher that brings in the B values.
We ready to activate Windows?
Alright. Yes.
Have you guys watched the video? Does that pop up? The big blue screen pop up when it does that? Or what does it look like? Holly? You don't know. Nobody watches the lesson videos, Mr. Bates. You could say anything.
I only watched like the end of it just to hear my voice.
Maybe what I'll do is is for between 3rd and 6th period both. Every day when I do actually no, it'll have to be one kid in 3rd, one kid in 6th. When I post my lesson videos, some point during the lecture every time, I'll cover my mouth and I'll whisper something really low, right? And then like the student that comes to me in the beginning of the day before any other and be like, "You said this!" They'll get some extra points or something. See if they'll find it.
I will watch the video just for you.
See, you need the points more than anything. You're not starving. All right. All right. Nope. I wanted this. Oh, I'm on that. That's what's going on. All right. Focus, children. So underneath this one, first things first, let's go ahead and label our points. Eyes up here, okay? Mr. Roberts, go ahead and label my 3 points. Did he say it? I didn't hear him. Okay. Mr. Roberts, what is my center, quote unquote? +3. Mr. Roberts, what's my center? 1, 2. So this is my HK. That's nice. But now if we look at it, normally I go out 1, then up 1 and down 1. Okay? I'm still going up 1 and down 1, so I don't have an A value here because my up and down hasn't changed. I'm still up 1 and down 1 from my center point. But now I'm out how many? What's my horizontal change? 2. My horizontal change is 2.
Up or down one and then out of two.
Right.
Okay.
So, and Dimitri points out I'm starting and ending in the wrong direction. So I am reflected. Since I'm reflected, I know that I have a negative out front. Yeah. Huh? We got to build it first. I'm starting it right now. I'm starting it with words so I know what's going on. Then my center is 1, 2. So that means H is 1, K is 2. Now here's the thing we got to think about, Sione. I'm horizontally expanded by what? By 2. I'm horizontally expanded by 2, which means, let's see how well our memories work. B equals Anybody? Hand? Nobody? B equals? Isaac? No. Nobody can say I did it. I waited too long for people to answer that. Nope. Nope. If you weren't brave enough to raise your hand and say it, then it doesn't count.
Isaac was telling me that I'm wrong.
Okay, wait.
Hey, you allowed him to bully you into not answering.
No, I bullied him.
Isaac, quit bullying him. And Richard, quit bullying him back. Yes, Kaya.
In relation to B, what is Y? Like I'm trying to. What is this coming from?
I don't know. That question didn't make sense to me, Kaya.
Okay. B is 1/2.
Yes,
How do we get it in that equation?
Right there.
by writing it.
I know. I mean,
Down 1 over 2.
like Y equals what? Is there like like let's say element OP minus H, like
No.
No, okay.
So explain to me how 2 got in there for K.
Well, because it's horizontally expanded by 2.
No, it's horizontally shifted to the right by 2.
Shifted to the right by 2.
To the up 2.
Up 2.
So this means horizontally expanded by 2. That's what that means. Because when you're right, because that's to the right one. Because when you're inside, you're doing opposites. So this means to the right one, and this means multiply the horizontal by 2.
I'm just wondering where we got B.
Oh, the distance over, from the dot to the next dot.
Yes, I know, but why does it equal B? What is
Do we
B? Is
need?
just like whatever.
B is your horizontal expansion or compression.
Okay, that's what I needed. I'm
Okay,
sorry.
you're good. I was just trying to help you get there. I didn't know what you meant.
Do we need 1/2? Like, or can we just put 2?
No, 2 would be a horizontal compression by 1/2.
But you're just writing the equation that it
Oh, I
shows.
don't like that.
Yeah.
It's reflecting.
The negative takes care of the reflection. The 1/2 takes care of the horizontal stretch by 2. To the right one and up 2 to get my new vertex.
How does the half take the?
All right. I don't like saying it this way because it's not a slope. It's not a slope. Let me make that 100% clear.
Sounds like slope.
It is not a slope. It just so happens on a cubic, we standardly go over 1, then up or down 1. It just so happens. It's not a slope. But if it helps you wrap your mind around it, it's not.
Slope. It sounds like it. It looks like it too.
See, we learned so much to the point where we think it's a slope.
You say it's a slope. Okay, looks like a slope, sounds like a slope. Let me connect those dots. Does that line follow the curve? No. By the time I'm here, I'm way different. That is not the line of best fit. Okay, let me get to this one. There you go. Did it hit that dot? No. Okay.
Just move it more to the left.
Look, folks, if you want to argue with it, fine. I get to grade it. So it sucks to be you. All right?
Can you explain it again? Is
I'm not.
it our time to leave?
No, nowhere near. Okay. But, guys, it's not a slope. However, if it's on the inside,
Sorry.
if it's on the inside, you can look at it like this. In this particular example, I am not standing by this. This is a maybe, make you understand. I am not standing by this as some general rule that you can apply everywhere. No. What is slope? Nope, give me something different. There you go. Down 1, run 2.
Yeah, that's what I just wrote.
Yes. So that's why my B is 1/2. If I wrote 2, it would mean I'm rising 2 and only going over 1. And I would have gotten a point here and a point here. Those aren't my points. My run was 2, my rise was 1.
So B changes.
Yeah, it could. Absolutely. All right. Not standing by that. All right. Yep. Yes, see, One, if you have to ask that question, it means that you did not understand the lesson. I'm telling you what it means. I need you to understand that. If you have to ask, so that's the answer, it means you did not understand the lesson. Do you understand what I just said? Yeah. Okay. No, but do you understand that statement? Yeah. If you ask, so that's the answer, then it means you learned nothing. Right?
I knew everything else besides the other one.
Where'd they go, babe?
Because if I wrote... What? Oh, yeah. Because nobody says, so that the answer? Yes, you don't ask that. Why? Because you understand that that's the answer.
I was asking what I asked earlier. If it's going to stay g of x or if it's going to be y, if it's going to be x.
Oh, I'm saying y. I'm down with y. All right, next one. Oh, frustrating children. This one's an easier example. I wrote this. I wrote this, Bethany. Bethany, what's my new center?
It is -2, 1.
Yep, there's my HK. Am I reflected at all? No. Starting low, ending high. I'm good. What's my am I changed vertically or horizontally? Vertically, I'm still going to the right 1. My next dot is up how many? 3. So, I'm done. My A value is 3. It's not negative because I am not reflected. I move to the left 1, which means, or sorry, to the left 2, which means it's +2 on the inside. And I moved up 1, so it's +1 on the outside. My HK. H and K are right there.
Plus, you go opposite. Oh, opposite signs.
On the horizontal stuff, it's opposite. Horizontal stuff is opposite, yeah.
I get this way much easier.
This should be way easier than matrices. Guys, please start 3 and 4.
I did. I finished it.
Simplify that.
Simplify? You did finish it.
1 over 1.5.